In this lesson, we are going to learn about the basic principles of a camera. Look how happy the family is to have their family picture taken. The boy is using a camera to take the family pictures. Have you ever wondered how a camera works? A still film camera would have three basic elements: an optical element, the lens, a chemical element, the film, and a mechanical element, the camera body. These elements are important in a camera to capture the image of objects, people, landscape, or scenery. A still film camera can be divided into two: the single-lens reflex camera, SLR, and the rangefinder. The main difference between these cameras is the way photographic scenes are displayed, accessed, and processed in a viewfinder. A single-lens reflex camera, SLR, enables the photographer to focus from the viewfinder the same image that is exposed on the film. While in a rangefinder camera, or point-and-shoot camera, a static and secondary image is needed to be matched for the focus to be achieved. How does a single-lens reflex SLR camera work? The optical component of a camera is the lens. A lens takes the beams of light reflected from an object and redirects them so that they come together to form a real image. In a lens component, basically, there are at least 3 or more lenses that are used to focus the image onto the film and through the viewfinder. To enable better focusing, the arrangement and shapes of the lenses follows the optical principle of light. To enhance the focusing, a photographer needs to adjust the distance between the lenses or adjust the focal length of certain lens. When a beam of light enters the lens at an angle, it bends in one direction, and when it exits to the air, it bends again. For a plano-convex lens, the beams of light passing through it will bend towards the center of the lens on entry, while for a double convex lens, the beams of light bend when it enters or exits the lens. How does light travel through the lens? The light path through the lens depends on 2 factors: the angle of the light beam's entry into the lens and the structure of the lens. What is the relationship between the object distance and image distance? When the object distance increases, the image distance decreases. Therefore, light beams from a closer point converge farther away from the lens than light beams from a far point. The real image of a closer object forms farther away from the lens than the real image from a more distant object. The angle where light enters changes when the object is closer or farther away from the lens. As the lens moves, the focused real image of an object lined up so it falls directly onto the film surface. Light beams that enter at a sharper angle will exit at a more obtuse angle, while light beams that enters at a wider angle will exit at a more acute angle. How does the girl know that she is seeing a real image? What mechanism enables the girl to see the focused image before it is captured on the film? The camera lenses produce an inverted image. This image is reflected by the slanted mirror into the pentaprism that flipped the upside-down image so that it appears right side up again. The prism then directs the image onto the viewfinder window. If light is coming into the camera body, what stops the unfocused light from falling onto the film? The slanted mirror. It stays open as long as the shutter is open. The slanted mirror quickly moves parallel with the light so the image is directed onto the film. These steps are indicated by the sudden blackout of the viewfinder when the shutter button is clicked. Click on the blinking spots to see the light path.
Let's build our own pinhole camera. Click on the Step 1 button to start this activity. Materials needed: cardboard box with a removable plastic lid, black paint. Steps to build a pinhole camera. Paints the box inside and out in black. This helps light-proof the box. Cut a small hole about the size of a matchbox in the center of the box. Cut out a piece of heavy-duty aluminum foil or heavy black paper about twice the size of the hole. Make a small hole in the center of the foil using a needle. Tape the foil over the hole in the bottom of the box so the pinhole is centered. Attach the foil securely with black tape. For the shutter, we use a piece of heavy black paper large enough to cover the pinhole. Tape one side of the paper securely to the side of the box so it makes a flap over the pinhole. For the shutter, we use a piece of heavy black paper large enough to cover the pinhole. Tape one side of the paper securely to the side of the box so it makes a flap over the pinhole. Tape the other side of the flap closed on the other side of the pinhole. To load the camera, attach any sort of film or photographic paper to the inside of the box. Let's see how the pinhole camera produces an image. Click on the shutter.
A camera consists of 3 different elements: a lens system to create a real image, a light-sensitive sensor film to record the real image, and a mechanical system to control how the real image is exposed to the sensor.